Hello, I'm Umi Salima binti Hassan and my index number is 20211023122169. So today I will presenting task 2 of the Mathematics in Science project quadratic function. First of all, I would like to thanks to the Dr. Fan Xiang Peng for all the information, guidance and support provided to enable me to perform all these tasks successfully. Alright, I will begin this presentation by explaining introduction of quadratic function and how is it used in our daily life. Quadratic equation in real life are used in many fields and in everyday activities. Astrology, engineering, agriculture, science, military and sport are some of the fields that use quadratic equation. Quadratic equations are used in many real-life situations such as calculating the areas of an enclosed space, the speed of an object, the profit and loss of a product, or curving a piece of equipment for designing. One such real-life example is that if an object is projected, then the place where the object will reach the ground, the distance traveled by the object, and the time taken by the object to reach the peak height can all be determined using quadratic equation. Now, I will go over linear quadratic function greater detail. So, what is quadratic function? A quadratic function is one of the form open parenthesis s close parenthesis equal ax squared plus bs plus c, where a, b, and c are numbers with a not equal to 0. Where a and b are the coefficient, s is the variable, and c is the constant term. The first condition for an equation to be a quadratic equation is that the coefficient of s squared is non-zero term. The graph of a quadratic function is a curve called a parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U shape or N shape. This depends on the coefficient of s squared, or also referred to as the value of a. For real-life situation, for example, we know that as a rock goes upward, it experiences a force downward due to gravity of Earth, because of which the speed of rock will decrease and finally comes to stop at the highest position in the entire flight of the rock. Acceleration due to gravity always at downward. So let's have a look at the question.
So the question is,
a rock is thrown upward from the top of a 112-foot high cliff overlooking the ocean at a speed of 96 feet per second. The rock height above ocean can be modeled by the equation h open parenthesis t close parenthesis equal negative 19t squared plus 96t plus 112. When does the rock reach the maximum height? Maximum height the rock can reach is exactly at the maximum value of the graph, or can be set as at the parabola which is symmetric about a vertical line drawn through its vertex. This line is called the axis of symmetry. The equation for the axis of symmetry is s equal negative b over 2a. From the equation, h open parenthesis t close parenthesis equal negative 16t squared plus 96t plus 112. We must simplify it in the form of a, b, c, where a equal negative 16, b equal 96 and c equal to 112. Now enter these values into the formula. Negative 96 divided by negative 32 equals to 3. Thus, the time when the rock reaches the maximum height is when t equals 3 seconds. So next question, what is the maximum height of the rock? From question A, the rock reaches the maximum height when t equal to 3. Therefore, we just need to replace the value of t in the function with the value of 3 to get the value of h, which is the height of the ball. Thus, the maximum height of the rock is h equal to 256 feet. Okay, for last question, when does the rock hit the ocean? To answer this question, we need to know that the graph will hit the ocean when the height of the ball is 0. Thus, we need to find time when h is equal to 0. We can use the factorization method. As we know, a quadratic equation will produce two values of root, and for this equation, the root or t value is t1 equal to 7, t2 equal to negative 1. Consider the roots logically. Negative 1 cannot be the time when the rock hit the ocean because it is a negative number. So the other solution, 7 must be the exact time when the rock hit the ocean. Thus, the rock hits the ocean 7 seconds after being thrown. So when all the equations have been answered, we have all of the information we need to construct a quadratic graph. We know that the y-intercept is 112 and the graph is N shape based on the given function because the value of c is 112 and a is less than 0. Question A and B provide information about the graph maximum point, which is 3 and 256. Finally, question C clarifies the x-intercept of this graph. So D is a complete graph to the equation h open parenthesis t close parenthesis equal to negative 16t squared plus 16t plus 112. From the calculation above, we can conclude that we can manipulate quadratic equation by changing the various coefficients, and no graphing can always find 0. Sometimes there are decimal approximation. To summarize, it has been demonstrated that quadratic equation not only solve mathematical problems but also our daily problems without us realizing it. That's all I have to say. Thank you.